why did you come here? Like, gotten so many balls. She said, why did you like it? And I
No. You have 7-day-2 applications of differential equations. Show that y equals 2 plus x log x, where x is a big solution for the difference equation. X squared y prime plus y equals 1, given in this condition of y1 equals 2. So first thing I had to do is get y prime by itself.
should freak out when how fast what you're in should be honest. This portrait is talent. Or people what? I remember the thing where it was like prove that sine cosine equals cosine squared. Yeah, we something like that. Yeah, that's just what this is.
So what I'm going to do first is get y prime by itself. So
Wait, isn't it just saying y, not y prime? Isn't it just saying y?
I still don't know how to do it, but
so first sitting x squared y prime equals 1 minus xy, and then divide by x squared. So y prime equals 1 minus xy over x squared.
and then you just take the antiderivative of that. Equal what?
Take the antiderivative of that. Because we haven't done antiderivatives with x and y. Yeah.
Well, I mean, that's eventually. I feel like that would probably be the easiest because you have to get y to equal y.
Wait, how is y prime is hold on. Okay, yeah. Wait, I think I just need to give me an answer.
That's a valid.
I need to
Just give me like 15 minutes.
Yeah. So how did you get what y prime is?
But I think it was the inheritance to y prime by itself.
Oh,
Right.
I have no idea.
So function given addition.
Interesting. Yeah. Yourselves.
This I'm trying to figure out where I really want. So, here.
Just don't have to do this thing. You know, like, and walk. Monday. And I was last night, I was. And I went color one.
Let's take this and plug it in for y.
Alright.
So we get y prime is now equal to 1 minus x times 2 plus natural log of x over x squared. It's clear. There in the sun. Oh,
Not plugging it in.
why?
I think it's.
He can, like,
Why not just plug in
So
two?
I'm looking at you guys.
Actually, you have to.
You just can't do it.
Yeah, you just can't let it.
Like, that's all. I have crazy vision.
What happens to executive here?
Cancel out.
You can't.
So we get 1 minus 2, right? Just say so. Just say it.
No, yeah.
So we get -1 minus natural log of x
Back
over x squared.
I think.
We get -1. Cause 2 minus
Okay.
2.
Minus, yeah.
Whoa. 1 minus 2. Whoa.
Oh, yeah. The minus here, -2 minus natural.
Oh, you got it, yeah, negative. No, I was gonna get it. Minus element. Oh, it's the times. That still does not equal.
How do we get
Can
the
we
y?
just bring the x up? Oh, it's that it's a solution of an equal.
Make sure we're all good to here.
No, no.
So this is what y prime equals, right? We can say this is y prime.
How'd you get one?
Put this
One
into
minus 2. Then how did they make it?
y prime.
1 minus 2. Wait, I'm not.
So this is what y prime equals. We can plug it into y prime.
Okay, I see.
In this case, we're going to solve for y. So we have x squared times
The y.
-1 minus natural log of x over x squared plus xy equals 1.
Wait, we're solving for y?
What's the x squared? So we get
No, wait.
-1 minus natural log of x plus x y equals 1. If I want to get, sorry, should be x, y. If I want to get y by itself, what would I need to do?
Wait, hold on. Wait, wouldn't you just like make? So doesn't that show that it's a solution, so wouldn't you just solve?
We're going to do the,
Y, oh, I got it, y is equal to 2 plus ln x over x. And then we plug in 1 equals 2, boom. Do we have to plug it in anymore? Machine.
so if I add 1, add log of x, 1, add natural log of x, you get x, y is equal to 2 plus natural log of x. And you get y by itself, what do we do? Add x, y by 2.
Good job.
Which is-
literally that.
showing that if we plug in for y, we get what y prime equals. So if we plug in that in for y prime, we get back to where we were.
What was the information like y1 equals 2? What was that?
Honestly, don't know what it really equals.
Because it said like, given the initial condition. Just check it work out.
Let's plug them both in. See what happens.
I see this on the.
I love it. But like I feel like you needed that.
Let's see what happens. If y1 is 2, so let's plug in 2 for x. Or plug in 1 for x. What do we get?
I mean,
If I plug in 1 for x, I get 2, right?
You can't write the answer.
Right.
Wait, I didn't realize those were the same.
So y equals 1 or 2 plus natural log of 1 over 1. Well, natural log of 1 is 0. So y equals 2. So when x is 1, y is 2. Is that correct?
Yeah. So you just use it to check your work.
If I
Oh no.
Simpling different equations to possible solutions, no functions may be solutions to more than one equation or to none. An equation may have more than one solution. Justify all your answers.
How are we supposed to justify our answers if you didn't give us enough room? I'm pretty sure we didn't.
Small.
You just rewrote the
I
file.
think you should very small. Yeah.
Yeah, that works so well. Hey, just let me just.
How do you get
Not
UID?
Alright, so again, you cross multiply, right?
What?
Oh, you can't do that.
We can't do a degree of it. Wouldn't it just be 1 over y dy equals
Yeah.
1 over.
1 over y, yeah, dy equals 1 over x.
I did my homework. I did the end of the PM.
Oh, see that.
Right? So then it's just.
So natural log y equals natural log x plus some constant. Now these are possible solutions, so the constant isn't involved here. Please. Oh, we get y by itself? E. Yeah,
Wait, did you integrate that?
the order of the antiderivative of 1 over. Yeah, basically, I integrated but did the antiderivative because they're the same thing. Integration, antiderivative, same thing.
Yeah, I know.
So, that means that y is equal to x. Right.
What are the x plus e to the same? Z.
Well, no, because if you do e on both sides, that's both out of box.
Here, what about c? She's not really.
It's not really relevant because c could be 0.
Okay.
So in all these, c is basically 0.
So, right.
So which one does this look like?
B.
So, okay.
It's not yet. Yeah.
There it is.
There's no room. Are you kidding? That's right.
So we could write this as what? Let's keep y as 1 over y, make it easy. So we have this 1 over y dy equals 3 over x. Yeah, right. Now this would give you the natural log of x, all right, natural log of y, sorry, equals 3 natural log of x. I'm not going to worry about c. Okay. What can I do with the 3, by the way? Yeah, the power. So natural log of y equals natural log of x cubed. And when I do base e, y equals x cubed.
So I'm pretty sure that was the.
I said one.
I'm confused as to how this is justified. Thursday. Are we just like, oh, never mind.
Do some blues, it's a different color here, so I'll mix stuff together. Right, so now, since we don't have a y here, we can just write this as 1 dy equals 3x dx, which is y is equal to what? As x squared. Do I have that anywhere? Nope. So C is not an answer to me.
Why do you do that?
It's in the solutions. Notes. Functions may be solutions to more than one or none. Equation may have more than one solution. So no solution. So in this case, none of these are applicable to this. Okay. Now for D, we have what? Bring up 1 over y dy equals 1 dx, which gives you natural log of y equals x, which means y equals e to the power of x. Do I have any e to the power of x?
No.
I do. I just have a coefficient, right? Now, coefficient 3 e dx. Not the c per se.
No, that's not enough. You say that's the answer. How? Like if you were with. And GL, that doesn't make sense.
What is
What if you have to be wrong? It's that way. He is so what? It's the same thing to three.
yeah, it just wouldn't make a difference if we had coefficient there.
What do you know? So that's always a rule. It's always a rule. Are you sure?
Yeah,
I'm just. Then how is?
because this is a possible solution, not a
But-
definite solution.
C has a coefficient and it changes the answer.
Yeah, c's not involved here. C's not a coefficient. C's a constant.
What?
C is a constant, not a coefficient.
Wait, solving. What did just maybe? But there's more than.
So we have what, 1/y dy equals 3dx. So the natural log of y equals 3x. So y equals e to the 3x. That was a bit easier.
Why is
D the answer? Why is 4 of D?
The coefficient wouldn't change, wouldn't eliminate it as being a possible, it's a possible solution. The coefficient wouldn't eliminate that as a possible solution.
This is when you do the red.
Yeah.
Goes away. Okay.
Now, with that in mind, all right,
That means
what kind of function is phi?
On the line.
And again, we just said that the coefficient of x would not affect that being a linear function.
it will also be a.
Yes. What?
It's basically saying what type of function it is. So since A, we got what? Linear functions. So 2 and 5 are linear functions. B, we got what? Cubic function. So 1's a cubic function. Which means if I had y equals 2x cubed, that would also be a possible solution. A possible solution. For C, we got what? Quadratic solution. Do we have any quadratic answers? No.
Yes.
D, we had an exponential function, and we have only one exponential function. Base E. And then E, we had an exponential function with 3x at the exponent. Yeah.
Are we all done for today?
And
We got.
oh, we got 3 pages of work. More pages. Okay, great.
Well, we have like 3 days for this.
We only did 2.
2.
Well, we could have. We did this.
It's off the list. Chapter 7, 8, 9, 10.
How many days are in this chapter? Or 10
Or
days? Friday.
Yeah.
So then we have plenty of time.
That's true. You know. Number 1.
Only one?
This one says, subdivide Jesus at the rate proportional to the existing amount of quantity, solve the following different numbers. So this is going to be just straightforward what we did the other day when we had those, we created the exponential functions. So here we have 1 over E dp equals 0.02 dt. What do we do when we integrate both of these? Natural log p equal to 0.02 t plus c. Natural log you what? So we get p is equal to e to the 0.02 t times e to the c. Now, what did we do with e to the c yesterday? And actually, last class. Actually, it was a class before. Why do we won't change the locations? What happens if I combine those bases? I would have the exponents. So you can separate it with multiplication. So just because if I have x to the y times x to the 2, that would give you x to the y plus 2, right? So you can go backwards. Now, what do you remember what we did with e to c before?
Let's see.
What kind of function is this? An exponential function. What was your initial value? What we always write our initial value as? A. So we could write this as p is equal to a to the e 0.022.
What is the constant?
Because e to the n constant is still constant. That's what we're going to do for 2 and 3. Now, keep in mind what we just did for 1. What's the answer number 2? And in this case, it would be p to what?
Surnames. Yeah. Why don't we put constants on both sides?
Because if you subtract or add constants, it's still constant. So you just bring all your constants to one side.
And you can take both sides.
Yeah. And you can do all the work that last one, but we pretty much just did the work. 1 and 2 are pretty much the same question, just a different next one.
That's the answer. I'm going.
Number 3 is a little different. Because what do you want to do first? Yeah, so dy over dt is equal to negative y 3. So dy over, well, 1 over y dy equals negative 1/3 dt. So now that we have stuff like this, kind of know what our answer is going to be, but just go ahead and process. Natural log of y equals negative 1/3 t plus c. Raise both these as bases. So y equals e to the negative 1/3 t times e to c. And e to the negative 1/3 t. So notice that all 3 of the above different equations have the same basic form or can be changed into the form of dy dt equals ky. So typical applications of this type are as follows. Exponential growth of bacteria culture, growth population, human, animal, etc. Exponential gain, carbon gain, half-life problems. Demand for person's resources, oil, gas, etc. Dissipation of direct concentrations in the bloodstream, absorption of light, all those Great. Here's contingency at a rate of 5% at current balance. Year assume initial deposit of 1,000 and no deposit probably comes made. How much money would you have that percentage in years? Now, to be honest, you already know the formula, right?
Yeah.
What's the formula? Yeah. So E-R-T. Okay. What they want you to do is to set this up as EP over DT. The rate of change is what? 5% per what? That's not. Yeah. Which would still give us what? If we do all the fun stuff, that'd be 1 over P dP equals 0.05 T. Natural log of P.
Wait. Wouldn't it be
DT, right? This is 0.05. So P equals E to the 0.05 T C, or as they like to write it, E equals A.
I'm sorry, what was, why did we put the between them? At the very end.
It's usual symbol principle.
Okay.
A equals.
Why did we do it?
Um,
Okay.
in the area of like line.
It's the same thing. It's just different letters.
So about, I'm so lost. Wait, so what's the answer? You know, something.
The whole idea was for you to know where this formula came from.
Well, so the answer is just, I don't think we've gotten the answer.
You know, we have to- so it's- the whole idea again is to understand where if we just you've been given these formulas in high school, you're going to just take them as they are, but where do they come from? This is where it comes from. So if you plug everything in, what's our initial amount? 1,000 e to the 0.05 for 17 years. And you just plug in the calculator. Approximately, because you're going to round to a penny. $2,339.65.
Wait, why don't we just do that in the very beginning?
It wasn't so much that, yes, you know the formula, but where did the formula come from? Why is that formula exist? Yeah. It's like, do you remember doing horizontal asymptotes? Like we know if the numerator has a greater degree, it's no horizontal asymptote. If the denominator has a greater degree, it's 0. If it's the same degree separation, when in this class, we learned why that's true. Because it's all about limits. So we know limits. Yeah. Horizontal asymptotes are about what the function is approaching as you go to infinity. So that's when we do limits at infinity.
I didn't figure it out. Where did we do this?
More or less, you need to know where the stuff is coming from. So if you don't have a specific formula, you can make a formula.
No.
Well, this one, yes, we knew the specific formula.
Oh,
So the population of the country is growing at a rate proportional to the population. If the growth rate is 4% of its current population, how long will it take for the population to double? So again, we do know the formula. I'm not going to go through the process. What's the formula again? P equals A e to the RT. And this gives us the rate. So in this case, we have P is equal to A e to the 0.04 t. Now we're trying to find t, and they don't give us p or a, but they kind of do. It's 2a.
we can just put like 1,000
Or just
one and two.
1 and 2. So 2 is equal to e to 0.04 e. And then how do we get t by itself?
I don't know.
Natural log of 2 equals 0.04 t, which means t is equal to natural log of 2 over 0.04.
Why is there not an A in this?
Because a was 1.
Where does it say that? Just, you know.
She doubled, so what's 2 times 1? I mean, you can put any number for p and a you want as long as p is twice a. So plug that in. Natural log 5 by 0.04. So a little over 17 years. 17 is 0.329. So 17 and a third year. When Dr. Riggins went to the refrigerator last week, she found some mold growing in some leftover cottage cheese. Okay. Instead of throwing out, she decided to let it grow in order to create this problem for you. If the number of mold spores increase continuously at a rate proportional to the number of spores present, write the differential equation relating to the amount of mold M as a function of T.
So the rate increases as time increases?
So the rate of mold increases proportionally to the time. Okay. Relating to the amount of mold. So the amount of mold would just be M itself. But you know the you have to have some coefficient value, basically some K value to find the rate.
One.
Because we know what K is. Where K itself will eventually be the actual rate. And find the general solution. Okay, remember all the equations, the whole process we had before, which was what 1 over M dm equals K dt, which gives you natural log of M equals kt plus c. So M is equal to e to the kt times e to the c. M is equal to a e to the kt. This came back to come speed 6 hours later. The amount had tripled. Use this information to find K. So that means in terms of hours, so T is 6 and M is 3 when A is 1. Result of K. So 3 is equal to E to 6K, which means left log of 3 is equal to 6K. K is equal to natural log.
Oh my gosh, no,
That's not that complex, is it?
I mean, no, but let's actually write it.
Over natural log 3, over 6. Okay, we'll go to what, 3 decimal places? 0.183.
Yeah.
Mole per hour. There's no units on there. Yeah. So how much mold spores would you expect it to be in 12 hours? What you don't need the initial amount. Okay. So M is equal to A e to the 0.183 times 12. M is equal to whatever that is. Rounding. What's about? Oh, so 9A. 9 times the initial amount.
Wait, so what happens is you use the hours to see. We can stop.
And.
But tomorrow we can cover new law cooling. 2 questions. Yeah, I'll get that after we finish.
You can go on. More. Oh, no.